What's up, y'all? I'm here with another solution for the week 9, day 1 classwork. This problem here comes from slide 5. It's problem number 1. And it's our first time, our first problem where we're using the rules of logarithms in order to solve an equation. So, something that's interesting here in this problem is that I have all these logs and they're adding each other, and I'm trying to solve for the value of x. Now, you'll notice that each one of these logarithms has the x inside of it. This is kind of similar to if I had some sort of problem where I had 4x plus x squared equals 6. I'd want to combine all my terms, or maybe I shouldn't have squared. Let's just have x. You'd want to combine all terms in order to solve it, right? And then by dividing both sides by 6, I would get equals 1. So x equals 1. In a similar fashion, we're going to want to combine all these terms, all these logarithms, into a single one, because it's going to enable us to undo the logarithm, right? In its current state, it's going to be kind of annoying to undo all these logs. But if I can get them to all be a single logarithm, then it'll be pretty easy. So let's start off by using some of these laws of logarithms. I noticed that I have a bunch of logs adding, so it kind of implies to me that I want to use the product rule, right? Because when you have two logs adding, they will combine as a multiplication of the insides. So a lot of people probably solved this problem with the following. They said, okay, log base 2, log base 2, log base 2, 4x, x, they're all going to multiply. So they got log base 2 of 4x times x times x, that's 4x cubed. And they have this 2 here, so they're like, oh, well, the 2 goes in front, right? Now, this is actually incorrect. There's a problem here, and the problem is this 2 that we just sort of brushed off on the side. Remember, if you want to do the product rule, right, if you want to, or even also the quotient rule, you cannot have any coefficients in front of your logarithms, okay? Remember, the coefficient is something like this 2 here, okay? A number which is multiplying in front. So I need to get rid of that 2 first. How can I get rid of the 2? I'm going to use the power rule, right? Remember, guys, the power rule essentially lets us move a coefficient in front of a logarithm into the exponent. Check that out. That's kind of cool there. So if I had y times log of x, the y could be brought into the exponent of x. So see how I have log of x to the y? Similarly here, my 2 could go into the exponent of x and become x squared. So I'm going to erase this guy, get him out of our way. So this should be rewritten as log base 2 of 4x. I'd recommend not getting lazy, by the way, of rewriting things when you're doing math. Because if you get lazy and you kind of don't write the base 2 there, for example, you might end up forgetting that it was base 2. So actually rewrite everything. Log base 2 of x plus log of x, log base 2 of x squared. I'm going to have to erase this crap out of the way. And it all equals 6. So all I've done here from this to here is brought the 2 into the power on x. Now I can use the product rule. So all these logs are adding, so I can multiply their insides. So what's 4x times x squared? It's actually going to be 4x to the 4th. And it would be log base 2, because it's supposed to be the same base as I had before. Another thing to keep in mind, y'all, you can only use the product rule if their bases are the same, right? See, these were all base 2, so that's why I was able to do it. So log base 2 of 4 times x to the 4 is equal to 6. Now, to undo a logarithm, when you're solving equations, to undo a logarithm, what you got to do is you got to just take both sides of the equation and raise them with the base. So what I'm actually going to do is I'm going to literally I'm going to rewrite this equation as 2 to the power of what I had. And that should equal 2 to the power of 6. essentially, oops. Essentially, guys, what I've done here is I have just said that, oh, if log base 2 of 4x to the 4 is equal to 6, then 2 to the power of that should be equal to 2 to the power 6. That's actually the most common way to undo a logarithm. Because watch, now 2 to the power of log base 2 are inverses of each other. That cancels out, actually. Remember, anytime you have an exponential raised to the power of a log and they have the same base, they cancel. And I'd be left with 4x to the 4 equals 2 to the 6, which 2 to the 6, let's see, what's that? That's 2, 4, 8, 16, 32, 64. All I did there, guys, was I was counting by the powers of 2. I counted 6 of them. I was using my fingers for that. All right. Now to solve this, we just got to divide both sides by 4. Divide both sides by 4. So x to the 4 is equal to 64 divided 4 is 16. And I'm going to do a fourth root. Notice I'm not doing a square root, guys. I'm doing a fourth root. Fourth root. The fourth, luckily for us, 16 is actually a perfect quadruple or I don't know what the right word is for square, cube, quad, tetrad. I don't know. Basically, 16 is 2 to the power 4, right? So the fourth root of 16 should equal 2. And that's what we would get for x as our final answer. Oh, there's one quick thing, guys. Notice, in the same way that if I ever have x squared and I square root both sides, remember you're supposed to get plus or minus 2. Same thing here. I should actually have a plus or minus. So actually, I would end up getting x is equal to plus or minus 2. And that's my final answer. So to kind of quickly recap what we just did, let's see. What did we just do, y'all? Now I'm getting OCD to fill this in more because I felt like it wasn't highlighted enough. Here, should we add highlights? All right, now I'm just fucking around too much. So to recap what we did, we first used the power rule in order to get rid of the coefficient because I wanted to use the product rule. We can't do it though because there's a coefficient, so we used the power rule. Then we used the product rule, and then we used inverses. We said, hey, an exponential is the inverse of a log, so I can use that to undo the log in my equation. And we solve. All right. See ya on the next one.